Here we look at a second example of working out the pH after mixing a strong acid and a strong base. But this time I'm given the Kw, which is a strong hint that I might have an excess of hydroxide ions. So I've been given the concentration and volume of my strong acid, which is sulfuric acid, and the concentration and volume of my strong base, which is sodium hydroxide. So again, first step is to work out moles of hydrogen ions. We can see here now, I've now got sulfuric acid, which is a diprotic acid. So remember that the concentration of hydrogen ions is going to be double the concentration of hydrochloric acid. The number of moles of hydrogen ions, therefore, is going to be double the number of moles of hydrochloric acid, of sulfuric acid. So the concentration is 0.100 times the volume, which is 20.50 times 10 to the minus 3. Now that there would give you the number of moles of sulfuric acid, but we need to times this value by 2 to get the number of moles of hydrogen ions. And when you do that, you get 4.10 times 10 to the minus 3 moles. And that's the first point there. You've now got to work out your moles of OH minus, which again is a strong monoprotic base. So the moles of NaOH will equal the moles of OH minus. So that's going to be 0.2 times 25 times 10 to the minus 3. And that gives me 5.00 times 10 to the minus 3 moles. And we can see now that I've got an excess of hydroxide ions. So I've got to work out the moles of OH minus in excess. Which is obviously this number here minus this number here. So that's going to be equal to 5.00 times 10 to the minus 3 minus 4.10 times 10 to the minus 3, and that gives me 9 times 10 to the minus 4 moles. Next step, remember, is to work out my hydroxide ion concentration. It's the step which, again, everyone seems to forget, but we've got to work out the concentration of hydroxide ions, which is 9 times 10 to the minus 4 divided by, again, it's the total volume, so it's going to be 20.50 plus 25, which is 45.50 times 10 to the minus 3. And that gives you a hydroxide ion concentration of 0.0198 moles per decimetre. Now we need to now use this Kw value given here to work out my hydrogen ion concentration. So remember now that H plus is equal to Kw over the hydroxide ion concentration. So that's going to be equal then to 1.00 times 10 to the minus 14 divided by my hydroxide ion concentration of 0.0198. And that there gives me a hydrogen ion concentration of 5.05 times 10 to the minus 13 moles per decimetre. And then obviously I need to work out the pH of that, and therefore the pH is going to be equal to minus log to the base 10 of the hydrogen ion concentration. That gives you a pH of 12.30, and that there is your answer. If you've got an excess of base, you're looking obviously for a pH of well above 7. So that there is how you'd work out the pH of this mixture. Remember, moles of hydrogen ions, moles of hydroxide, moles of whatever is in excess. Then remember to convert it into a concentration. Now, because you've got hydroxide ions in excess, you then need to work out the hydrogen ion concentration using this equation. Once you've got that, hydrogen ion concentration, you can then use pH as minus log to the base 10 to work out the pH.